Hey guys, welcome to 3.1 Extrema on an interval. In this lesson, we're going to be able to use derivatives to find our absolute maximum and absolute minimum of a function on a closed interval. So let's go ahead and begin with the definition of extrema. So I'm going to let you guys read this on your own. And then I also want you guys to move on to reading the definition of relative extrema. So go ahead and pause the video, take a look at this definition, take a look at these definitions, try to make some sense out of them, and then play the video, and then we're going to go ahead and talk about what these are in the example below. So now that you have read the definitions, let's go ahead and take a look at the example below. In the figure on the right, on the interval from -2 to 4, f has an absolute maximum at, well, absolute maximum. What is another word for maximum? The highest. So f has the highest point at where? Well, at this point right here. This is my absolute max. It's my absolute maximum. So it's the point 4, 21. Why is it the absolute maximum? Because at 4, f of 4, which we know is 21, is greater than f of x for all x in -2 to 4. So what I just wrote down may not make any sense, but let me make some sense out of this. If you go back to the definition above, a maximum says here that if f of c is a maximum, then f of c is greater than or equal to f of x for all x in I. And I was defined to be an interval. And I can be any interval. It can be an interval a to b, where a and b are real numbers. So if you look at this over here, I pretty much mimic the definition from absolute maximum. And I can do the same for minimum. My absolute minimum value is the point -2, -15. Again, this is -2. So f of -2 is the lowest point, so it's less than f of x for all x in the interval -2 to 4. So these 2 points here are defined as your absolute max and your absolute min. But what is relative max and relative min? How is it different from absolute max? And I'm going to go ahead and explain that right now. So let me go ahead and erase this so that I don't have too much stuff here. So a relative maximum occurs when you have an interval containing a maximum in an interval. So for example, I'm gonna choose this to be my interval. Okay, notice I didn't designate any values, but from here to here I have an interval. And do I have a maximum containing this interval? Well, yes, I do. My relative maximum is 0,5. So on some open interval, I have a maximum, and 0,5 is my relative maximum because my graph goes from up to down. And at the highest point, I have a c value which is higher than any point around this interval. Now I can do the same thing for minimum, relative minimum. If I choose an open interval around this lowest point, then there is no other point in this interval that I chose that is lower than 2, 1. So 2, 1 is considered to be my relative minimum. You could also say it's a relative minimum because the graph goes from down to up, and at the lowest point is my minimum. Now the next thing I want to talk about is your critical numbers and critical points. Let f be defined at c. C can be any x value. If f prime of c is equal to 0, so if the derivative is equal to 0, or if the derivative is not defined, which means f is not differentiable at that c, then c, which is an x value, is called a critical number of f, and the point c comma f of c is called the critical point. Now, put a star next to that definition because we're going to come back to it in the problems below. The next part that we're going to be talking about is the theorem. It says here relative extrema only occur at critical points, at critical numbers. So we already know what a relative extrema is. A relative extrema is when you have a maximum and a minimum on some sort of interval. Okay, so for example, if the graph goes from up to down, I have a max. If the graph goes from down to up, I have a minimum. Okay, so let's go ahead and talk about max and mins before we get into critical points. So in the examples below, name the maximum and the minimum of the points if possible. Letter A, I have a curve on a closed interval, A to B. Well, not necessarily A to B, it's defined now to be -1, 2, 2. It's closed because I have solid dots right here and here. Okay, so what is the absolute minimum of this graph? Well, the absolute minimum of the graph is right here, and what is that point? That point is 0, 1. The absolute max, it cannot be this point, it has to be this point right here, and that is the point 2, 5. Now, letter B, we have the same graph except now we have an open interval on what, I'm sorry, we have this to be closed and this to be open. So from -1 to 2, but not including 2. My minimum, is my minimum defined? Well, yes it is. I don't have a hole here, so it's defined. So my minimum is still the same. However, my maximum is not defined because of the open hole here. What does an open hole mean? An open hole means that you have a point that's really close to 5, but not exactly 5, because 5 is not included. So do you really have a maximum? Well, you don't. It looks like you do. It looks like the maximum is 5, but it's not, because what's a number really close to 5 but not exactly 5? 4.9. What's a number closer than that? 4.99 and 4.99, and I can keep on adding 9s and 9s over and over, and I'll never ever hit 5 because I'm not exactly at 5. So the maximum does not exist here. Look at letter C. My maximum is defined because I have a closed circle, so my maximum is 2, 5, and my minimum is not defined because I can get really close to 1 but not exactly 1, so that means that my minimum is not defined. What conditions are necessary to guarantee that there will be a maximum and a minimum? Well, I'll let you guys handle that. So I want you guys to go ahead and think of that on your own. So I'm going to go ahead and stop the video now and do a part 2 of the rest of the worksheet. See you guys there.